Okay, we're going to have a look at tree diagrams, which are a visual way of showing all the different things that can happen with probability. So looking at the first question, we have a tree and it has odd and even at the end in blue. Now, what this means is we're going to have, let's say, rolling a dice, and we roll the dice, we have a 23% chance. So let's try that a little bit larger so you can see it. 23% chance of rolling an odd number on the dice. So we're being asked, what's the probability of getting an even number? Now, one thing with tree diagrams is it's really easy to fill in missing parts of the tree. So, for example, the part of the branch that has a question mark on, there's nothing written there, there's no number. So we have to figure it out ourselves. And with each branch, we use the fact that probabilities have to add up to a whole one. So if it's in decimals, it'll add up to 1. If it's a percentage, it'll add up to 100%. If it's kind of quantities out of a total, it'll have to add up to the total. So what adds up to 100% with 23%? So you do 100, take away 23, and it should get you 77. So there is a 77% chance of rolling even on this dice. And a little note with that, with a normal for regular dice with 1, 2, 3, 4, 5, 6 on it, it should be 50-50, odd and even. So this could be a dice that has more odd numbers on it than even numbers, or it could be a dice which has a weight in it, and the weight is making it land on even more often. So it's the same principle with question 2. Now this is weather. Is it snowing or not snowing? So let's say it's the middle of the winter. We're in a country where it snows quite a lot. And again, I'll just write the number a little larger. The chance of snow is 0.88. Again, that's given to you in the question. I'm just writing it again so you can see it properly. So if you have an 88% chance of it snowing in this particular location, what is the chance of it not snowing? So it's written as a decimal, but so it's going to have to add up to 1. What do we add on to 0.88 to get 1? So you could do 1 take away 0.88. Maybe you've got a calculator. Maybe use a column method. Think about it as a percentage if you like. It's 88%. So you need to add on 12% to 88% to get 100%. Or written as a decimal, 0.12. Now, it hasn't been specified how to write the probability. So if the information you're given is given as a percentage, write your answer as a percentage. If it's written as a decimal, write your answer as a decimal. And if it's as a fraction, write your answer as a fraction. Unless the question specifically says, yes, we've given the information to you as a decimal, but please write the answer as a fraction. So just watch out in the question for when it's asking you to write down for the answer. Moving on to question 3, we now have a tree diagram that has 3 different alternatives. So we think about maybe the probability of picking sweets out of a bag, and we have caramel, mint, and toffee sweets. Even though there are now 3 different options, they still add up to a whole one. So the probability of caramel was 9. So again, let's write it a little bit bigger so you can see 9%. Probability of mint is 46%. And the probability of toffee, we don't know. Again, even though there's 3 things, it still adds up to a whole one. So add those together, 9 plus 46 will give us 55. And what do we add on to 55% to get 100%? It would be 45%. So the probability of toffee would be 45%. Moving on to question 4. So now we have a selection of colours, black, pink, and indigo. So you can imagine maybe you've got a lot of paints in a bag, and you reach your hand in, you're picking out random paint. What's the chance of picking each? Now we have mixed units. So indigo has 0.89. So again, let's write that a little bit bigger for you. And pink, it's not as a decimal. Pink, it's 2%. Now what we want to do is work in one type of unit. So use whatever's easiest to you. So 2%, I've already written a decimal down. So 2% as a decimal would be 0.02. But if you're like 89% and 2%, that would be absolutely fine as well. And thinking about it in terms of 89% and 2%, altogether that's 91%. So we need another 9% to get up to 100%. So the probability of black is 9%. So write it as a percentage, my final answer, but on the diagram, I'll write it as a decimal. All 3 of those numbers add up to 1. And again, I've not been told how to write the answer, so either 0.09 or 9% should be absolutely fine. Moving on to question 5, we have another selection of colours, but this time it's written as algebra. So the probability of picking white is 6x, x being a missing number. The probability of red is 1x, and the probability of blue is 3x. We've been asked for the probability of red. So it's not written as a percentage. It's not written as a decimal. This is going to be a fraction question. What's the probability of red? So we're going to write down the outcome for red, which is x. And then that's going to be over the total. So 6x plus 3x is 10x. So probability of red is x over 10x. Now, I said that these always add up to a whole one. So they always add up to 100% or 1, depending on what number system you're using. So all of these should add up to, let's say, 100%. So if 10x is equal to 100%, because again, the total is going to be a whole one, then if we divide by 10, we can solve the equation. 10x divided by 10 is 1x. 100% divided by 10 is 10%. So x represents 10%. Now we know what x is, we can actually go through and work out all the probabilities. So white was 6x. So 6 lots of x, which is 10%, 6 lots of 10% is 60% chance of white. Red was 1x, which we know is 10%, and blue is 3x. So 3 lots of x, 3 lots of 10% is 30%. And again, they all add up to 100%. So the probability of red, we could write a better answer. We could say there is a 10% chance of choosing red. Now, those easy tree diagrams, pretty simple. You're thinking, why do I need that visual representation with the easy questions? Well, now look at the medium questions. We now have more complicated tree diagrams, and these represent 2 choices. The first row in the tree, which I'm going to highlight in pink, this represents the first choice. So for the first question, you can choose yellow or pink. The second column represents the second choice, where again, you can pick yellow or pink. And we can see there are 4 possible outcomes to the tree diagram. This all depends on what route you take through the tree. You always start at the point on the left and you work your way through to the right. So for example, you could choose yellow and then choose yellow again. For an outcome of having a choice of 2 yellows, you could choose yellow and then choose pink for an outcome of yellow, then pink. And just notice how the first part of that route followed the same path. They both had choose yellow first. Then they diverged for the second choice, where we picked either yellow or pink, giving us 2 different choices from that first choice. Then we can have a choice of pink and then yellow, which will give us an outcome of a pink first and yellow second. And the final possible choice is you could choose pink, like we did last time, then choose pink again. And that'll give you an outcome of pink twice. So you can see, if you're choosing 2 colours from a bag, there are 4, and you're only choosing twice, there are 4 possible things that can happen. Choosing a yellow then a yellow then a pink then a yellow, or a pink then a pink. So when you're looking at the number of outcomes, you're looking at the right-hand side in the final column. The next thing is how do we calculate the probabilities? So for yellow, I'll just write it bigger. It's 3/8. This information given to you in the question, but it's quite small in the diagram. So I'll write it down again. And underneath that, we're being told that it's 5/8, but you could work it out yourself because every single tree, every single set of 2 branches has to add up to a whole one. And we can see that 3/8 and 5/8 add up to 8/8. They add up to a whole one. And not always, but for these diagrams, the second choices are often the same. So we're choosing yellow again, which is 3/8, or we're choosing pink again, which is 5/8. And then the same on the choices underneath. Now, a really important thing here, and we'll talk about this more with the hard questions, is that this says with replacement. And what that means is that if you pick a yellow out of the bag, once you've chosen it, you put it back in. So that means that if there's 3 out of 8 chance of picking yellow, there's 3 yellows out of 8 in the bag. And the second choice is also 3 out of 8. There's still 3 yellows because you put the original yellow back. And there's still 8 in the bag. With the hard questions, that'll change, but we'll talk about that when we get to the hard questions. So we've labelled our diagram. Now, the last thing we need to do is figure out the probability for each. Now, we go through a pathway, so let's highlight choosing yellow and then choosing yellow again. Because I said yellow and then yellow, when you say and in probability, that represents multiplication. That's supposed to say or. So, for example, you could choose yellow, 3/8, or red, 5/8. If you say or, that represents addition. 3/8 plus 5/8 is 8/8, a whole one. But I said and, 3/8, and then 3/8. That's a multiplication. So we're going to use fraction multiplication. Multiply the numerators. 3 times 3 is 9. And multiply the denominators. 8 times 8 is 64. So we have a 9/64 chance of choosing yellow then yellow again. And we use that for all the rest. So you could choose yellow and then pink. That's 3/8 times 5/8. 3 times 5 is 15 for the numerator, and 8 times 8 is 64 for the denominator. And you very often do get the denominators all being the same. Not always, though. We could choose pink, then yellow. 5/8 multiplied by 3/8. 5 times 3 is 15, and it's over 64. And the final one, we could choose pink and then pink again. 5/8 times 5/8. 5 times 5 is 25, and it's over 64. So all the denominators being the same is very, very likely. You get the odd question with or not. And then the middle two being the same, 15 over 64 or 15 over 64, that's also something that happens quite a lot as well. Again, not always, but most of the time the middle two will be the same. Now we can check our answers here because, again, every single kind of column in the tree diagram, every single pair of trees has to add up to a whole one. So, for example, at the start, the 3/8 and the 5/8 add up to a whole one. In the second column, we've got two sets of 3/8 plus 5/8. So each kind of pair of trees, pair of branches, adds up to a whole one. That's true of the answers as well. So 9/64 plus 15/64 plus 15/64 plus 25/64 should add up to 64/64. And if it doesn't, you know you've made a mistake. So now for the final step, now we've calculated all the possible probabilities, look at what the question asks. The question asks, what's the probability of picking yellow, then pink? So we start at the left-hand side. We need to choose yellow first, and then we choose pink second. And that route leads us to 15 over 64, which we can write down as our final answer. So the final pair is as simple as reading the value off the diagram you filled in. Moving on to question 2. We have some fruits in a tree diagram, and again, we're choosing 2 different fruits. So I'll write the probabilities down larger again. So for pear, it's 6 out of 10. And for mango, it must be 4 out of 10 because we've got to add up to 10 out of 10. And again, it's group with replacement, so it's going to have the same probabilities on the second part of the tree as well. So then we go through the tree and work at all the different probabilities. So pear and pear, 6/10 and 6/10. That's 6/10 multiplied by 6/10. 6 times 6 is 36, and 10 times 10 is 100. Pear and mango, 6/10 and 4/10. So 6 times 4 is 24, and 10 times 10 is 100. Mango and pear, 4 times 6 is 24, 10 times 10 is 100. And mango and mango, 4 times 4 is 16, and 10 times 10 is 100. Check that 36, 24, 24, and 16 all add up to 100. And if they do, you know you've got the right answer. And we need to read off the final calculation, which is the probability of mango, then pear. So for the mango route, then follow the pear route. And that leads us to 24 over 100. Now it gets a bit more complicated with question 3, but it starts off exactly the same way. So we have a tree, we have some numbers on it, we're choosing 2 colours. The probability of green is 3/9. So if green is 3/9 at the very start, with replacement, it's going to be 3/9 anywhere you see green. And then blue, it's going to add up to 9 out of 9, so it must be 6 out of 9. And anywhere you see blue will also be 6 out of 9. So now let's work out all of the probabilities, the green and green. So we're going to do the probabilities multiplied together. 3 times 3 is 9. 9 times 9 is 81. Green then blue. 3 times 6 is 18. 9 times 9 is 81. Blue then green. 6 times 3 is 18. 9 times 9 is 81. And then blue. 6 times 6 is 36. And 9 times 9 is 81. And again, this is a pattern you normally find. You normally find one of the numbers will be larger than the others. We've got the 36. One will be smaller than the others, so the 9. They might have 2 in the middle, which are the same, like the 18s. Now, we're being asked for the probability of 2 the same colour. So how's that going to work? Well, just write down all the different possibilities of choosing 2 the same colour. So we could choose green and then green, which leads us to 9 over 81. That is a way of getting 2 the same colour. Or something else could happen. We could choose blue and then blue. That's also 2 the same colour, and that leads to 36 over 81. Now, all the other alternatives, green and blue and green, they are different colours, so they don't meet the condition of having 2 the same colour. So what do we do with our 2 answers? Well, we need to add them together because we could have the pink route to get green and green, or we could have the purple route to get blue and blue. And because I'm saying or in probabilities usually means add. So we're going to add together 9 over 81 and 36 over 81. The denominators are the same, And adding the numerators, 9 plus 36 will give us 45. Now, make sure you follow the rules you normally follow when you add fractions. So the denominators have to be the same to add them. If you get a question where they're not the same, you'll have to use equivalent fractions to make them be the same, and then add together the numerators. One thing I'm not doing here is I'm not simplifying the fractions. You are occasionally asked to simplify them for an extra mark, but if you're not explicitly asked to simplify them, you don't need to. Because again, these answers give us information. We know that there are 81 different possibilities, and we know that 45 of them will give us 2 of the same colour. So we have information. Moving on to question 4, we have colours again. We have orange and brown, and orange is 3/5. So again, I'm writing that larger so you can see it. If orange is 3/5, anywhere you see orange will be 3/5 with replacement. So when we choose a colour, we put it back so it's available as an option to choose again. The probabilities have to add up to a whole one. So if orange is 3/5, brown must be 2/5. Anywhere we see brown, I'm going to write 2/5. Next, let's work out all the probabilities. So orange and orange, multiply them. 3 times 3 is 9. 5 times 5 is 25. Orange and brown, 3 times 2 is 6. 5 times 5 is 25. Brown and orange, 2 times 3 is 6. 5 times 5 is 25. And then brown and brown, 2 times 2 is 4. 5 times 5 is 25. Again, make sure 9, 6, 6, and 4 all add up to give you 25. It has to add up to a whole one. Then if it does, you can proceed. What the probability of at least one orange. So let's run through all the different alternatives from top to bottom and see if we get at least one orange. So if we do orange and then orange, we've got at least one orange. So let's write that down. 9/25. A common mistake here will be to not use this number because you have 2 oranges and the question says 1 orange. The key thing is it says at least 1. That means that 1's okay, but 2's okay as well, because if you've got 2 oranges, you do have at least 1. You've got an extra one, but you do have 1 orange. Look for other alternatives. So you could have orange and then brown. If you choose orange then brown, you've got at least 1 orange. The first one was an orange. And that leads to 6/25. And check every single possibility. So next, I'm going to check the third one that I've got. And that would be brown then orange. Well, that gives me at least 1 orange. Brown and then orange. And that's 6/25 as well. And then the final one is brown then brown. Well, if I've got 2 browns, I don't have at least 1 orange. I've got no oranges. So I'm not going to use that final one, 4/25. I'm going to leave that there. So what's the final answer? Well, I could have 2 orange, or I could have brown and orange, or I could have orange and brown. So I'm going to add them all up because I'm saying, I could have any one of these. Remember, we add up, keep the denominators the same, and add up the numerators. 9 plus 6 plus 6 is 21. Moving on to question 5, we have fruits again, lime and apple. And the chance of getting lime is 5/6. So again, make that nice and clear. 5/6 for lime. So it must be 1/6 for apple. We've got to add up to 6/6. So again, we're going to follow all our steps. We're going to fill in the diagram first, and then we're going to calculate the probabilities. So we could have lime and lime. 5 times 5 is 25. 6 times 6 is 36. We could have lime and apple. 5 times 1 is 5. 6 times 6 is 36. We could have apple and lime, which will give us the same. And we can have apple and apple. 1 times 1 is 1. And 25 plus 5 plus 5 plus 1 does give us 36. That would be 36/36, a whole one. So we know we've got that right. Now we're going to read the question, and we are going to check through what we've got. So we want one of each. So one of each will be lime, then apple. Or you could have apple and then lime. You can't have the other two because lime and lime isn't one of each, and apple isn't one of each. So write down the two that we've got. Those point to 5/36 and another 5/36. So again, if there's more than one possibility that satisfies the condition you're looking for, one of each, add them together. 5 plus 5 is 10, and keep the denominators the same. There is a 10/36 chance of getting one of each. Moving on to the hard questions, the important thing is now seeing this keyword, there is no replacement. I said with the medium questions that they did have replacement. So what does that mean? Well, let's take a look at the first diagram. We're choosing the colours yellow or green. So first, let's write down the probabilities a little bit larger. So for yellow, we have 3/10. And for green, we have 7/10. Now, the medium questions, we repeated those numbers all over the diagram because when we chose yellow or green, we put it back in the bag. It was back in the list of choices. This time, we're going to imagine, well, we've got a bag full of colours. We've chosen a yellow. So what's happened to the bag? The bag has got one less yellow, and it's got one less counter. So for your second choice, it's not a 3 out of 10 chance at all. It's a 2 out of 9 chance because we've lost one colour. And these probabilities have to add up to a whole one. So green would be 7/9. Now, the original green probability was 7/10. Now it's 7/9. What's happened to green? Well, there's still 7 green in the bag because we chose a yellow. We didn't choose a green. So we still have the full number of greens, 7. But because we removed a yellow from the bag, the total in the bag has now gone down by 1. So the probability of a green has increased from 7/10 to 7/9. Use the same logic for the other tree. So if we chose a green, we've gone from 7 greens to 6 greens. Or we've gone from 10 total colours to 9 total colours. So the probability for green would have changed from 7/10 to 6/9. And then yellow, the same thing would happen. As to add up to a whole one, it'd be 3/9. We still have 3 total yellows. That's not changed because this time, in this alternative, we haven't chosen a yellow. We still have 3. But the total in the bag has gone down by 1 to 9. And so you can see these are harder with no replacement because now all of the numbers on the second part of the diagram are all completely different. You have to spend a little bit of time working them all out. How do you know to do this or not? Every question is going to reference replacement or no replacement. It might use different words. It might say you've picked something and put it back in, and put it back in would mean that there is replacement. Or the question could imply that it's not put back in, and that would be no replacement. So while filling in the diagram is more difficult, as we've just seen, the rest of it is exactly the same. So we've done our first step, filled in the diagram. Second step is to multiply these together to work out the probabilities. So 3/10 times 2/9 would be 6/90. 3/10 times 7/9 would be 21/90, and the reverse of the second one. And then at the end, 7/10 multiplied by 6/9 would give us, still going to be over 90, and 7 times 6 is 42. So that process was exactly the same. And to check your answers, add them all up as usual. 6 plus 21 plus 21 plus 42 should all add up to 90. And then on to the third step, again, exactly the same as before. We want the probability of yellow, then green. So we'll follow the yellow path, then the green path, and see which number we get. And we get 21/90. Let's try that again for question 2. So we have cyan and black being chosen, 2 colours, and cyan is 6/10. That must mean for our first choice, black is 4 out of 10 to add up to a whole one. So if we choose a cyan, cyan's gone down from 6 choices to 5 choices, and our total has gone down from 10 choices to 9 choices. Each tree has to add up to a whole one, so black must be 4/9 to add up to 9/9. And then if we choose black, which is 4/10, choosing it again, 4 would go down to 3, and 10 would go down to 9. So cyan must be 6/9, so it all adds up to 9/9. Now the hard bit's over, we can do what we've done before, so multiply all the numbers together. So multiply the 2 cyans together, which will give us 30/90. Multiply cyan and black, 24/90. Black and cyan is also 24/90. And black will give us 12/90. Check that 30, 24, 24, and 12 all add up to 90. And if they do, for our final step, follow the path they've been told to do. Cyan, then black. Follow cyan, follow black, and we get 24/90. Now, question 3, we have colours again, navy and green. And I'm just going to rewrite the numbers a little bit larger. We've got 2/4 for choosing navy. Now, I could shorten that down and change 2/4 into a half. Now, the reason why I'm not going to simplify this, even though it would make the calculations easier, is that 2/4 gives information. It implies that we have 4 colours to choose from, and 2 of them are navy. And simplifying that to a half would get rid of that information. Now, you could simplify it, and you probably get full marks. But I'm just going to show you why we don't always simplify a probability. Green would also be 2/4 because it'd have to add up to 4/4. Also, if I shortened it to a half for navy, look what happens next. So when I've got a 2/4 chance of choosing navy, once I choose one of the navies, there's only 1 left, and there's 3 in total in the bag left over. Now, if I simplified that to a half, and I take a navy out, I've now got 0 navies, and now made it impossible to draw a tree diagram. So that's another reason why you shouldn't be simplifying these fractions. And of course, navy is 1/3, green would be 2/3 to make it into 3/3. Same with green. If we choose a green, We've got 2 different greens to choose from. We've taken one out. Now there's only 1 green left to choose from. And there were 4 in the bag. We took one out. Now there's 3 in the bag. So there's a half chance of choosing green. So navy again would be 2/3 as well, because it's got to add up to 3/3. So now let's multiply those together. So navy, then navy would be 2 out of 12. Navy, then green would be 4 out of 12. Green, then navy would be 4 out of 12. And green, then green would be 2 out of 12. 2 plus 4 plus 4 plus 2 adds up to 12. So I know I've got it right. What's the question asking me for the last step? Probability of 2 the same. We could have navy and navy, which would give us a 2/12 chance. Or, so we're adding, we could have green, then green, which is also a 2/12 chance. So add those up to the final answer, and that'll give us 4/12. Moving on to question 4, we have a choice of green and brown, and green is 3/5. Let's write that a little bit larger and think about these choices. If we have 3 green, then we choose a green, we've only got 2 green left. And we had 5 altogether. If we took one out, we'd have 4 altogether left. And then the 2 numbers have to add up to a whole one. The same for brown. We have 2 out of 5 browns. If we take a brown out, we've got 1 brown left out of 4. And so the other one must be 3/4 for those to add up to a whole one. Then add up all of the probabilities. So 3/5 multiplied by 2/4 is 6/20. 3/5 multiplied by 2/4 is another 6/20. 2/5 multiplied by 3/4 would be again 6/20. The last one, 2/5 multiplied by a quarter, would be 2/20. And 6 plus 6 plus 6 plus 2 all add up to 20. Let's look at the question. Well, the probability of one of each. So we could have green then brown, or we could have brown then green. So that is a 6 out of 20 chance for each of those. So we've got 2 different paths, can give us what we need, and altogether that would be 12/20. Moving on to the last question, we have a choice of brown or blue. Brown has a 3/9 chance, and blue has a 6/9 chance. So if we chose brown, 3/9 would go down to 2/8, and if we chose blue, 6/9 would go down to 5/8. Then fill in the rest, making sure they add up to 8/8. That'd be 6/8 and 3/8, and then do the set of multiplications. So we'd have 6 out of 72, we'd have 18 out of 72, another 18 out of 72, and 30 out of 72. And 6, 18, 18, 30 should all add up to 72. Then look at what we're being asked. What the probability of at least 1 blue. So what satisfies that condition? Well, brown and brown won't. There's no blue there. But brown and blue will. And that has a 18 out of 72 chance. Check all the others. So you could have blue then brown. That's at least 1 blue. And that's an 18 out of 72 chance. And you could have blue then blue. That's at least 1 blue because you've got 2 of them. And that's a 30 out of 72 chance. So adding all those together, 18 plus 18 is 36, and another 30 is 66 out of 72. Another way to check your answer here is look at the one we haven't chosen. The one we didn't choose was brown and brown, which is 6/72. If we add that 6 onto our answer, we get 72 out of 72. So getting at least 1 blue and not getting at least 1 blue adds up to 72/72. So it looks like we've got this right.